Hello again, James Greer here with the DFW Environmental Affairs Department. I'm here with Assistant Professor Nathan Brown from the University of Texas at Arlington with the Department of Earth and Environmental Sciences. Welcome.
Happy to be here.
Let's go in the creek and let's learn about some rocks.
So if you come to a stream like this, or any stream in your nearby park, you might wonder, what are all these deposits about? How old are they? Well, from this deposit, we can see little tracks of some critter running across it. So we know it can't be that old because it's not very solidified. In fact, I can pick up a handful of this stuff, and it's just like the beach that you'd see at the ocean. Totally loose, probably was deposited a year ago, maybe last week. What can we learn about deposits like this? Well, if I look here, I can see different layers. Now, each of these layers is pretty thin by itself. So I see a layer here that's maybe as thick as a penny or two. Maybe I see a foot worth of sediment that's been laid down. How long do you think it would take to put down that sediment? Maybe 10 years, maybe 100 years. Now, what would happen if we pressed the fast forward button on this whole system and we let this stream deposit for 100 years into the future and 1,000 years into the future? What if we let this stream deposit this sand for 10,000 or 100,000 years? What do you think would happen? Well, one possibility is that this whole valley that we're standing in would fill up with sand. And actually, that's what we see all around us. We see history of ancient rivers filling up ancient valleys with ancient sand. And we can learn about how long it would take to build that sand up, even though on any given day, all you're seeing is just a few little grains bouncing along. There's enough time that passes during the geologic past that we can build up whole thick sequences. And inside these sequences, we can learn things about the past, about which creatures lived in the past and what they were doing. So come with me over to the other hillside and we'll take a look. So we were just standing right over there at the river looking at the sand being deposited today. But if we turn around, we can look at this giant hillside and see really similar things happening. So right here, for example, I can see an ancient river system that was depositing its sand grains. Now you're probably wondering, how old are those? And you'd probably be surprised to find out they're actually 100 million years old. So another way to say that is these sand grains would have been around when the dinosaurs were walking around. They probably drank at the river that was depositing these grains. So when you walk outside your house, if you're living above some of this sandstone in the Metroplex area, there's a good chance you're looking at dinosaur sand, sand the dinosaurs would have walked around on. That's kind of cool. We can also learn things about how this sand was deposited, whether it was a giant storm that was laying down huge boulders, or whether it was a really gentle flow that was just carrying the finest of sand and laying it down one small layer at a time. These are the sorts of questions that geologists ask when they're looking at these thin layers of sand recorded in hill slopes. So beneath our feet, we see an entire layer cake of different deposits of all different types. And these tell a story of what was happening long before our time in the Metroplex area. Right now, we're standing about here. If we dig down beneath all the grass, beneath all the soil, we'd run into Woodbine sandstone. If you go to Dallas and you dig down, you'll run into a different unit. That's because all of these once horizontal layers have been gradually tilted through time, so that now, as you move from west to east across this area, you're walking up through these different age deposits and looking at their different environmental conditions. So What geologists have done is look at what's happening in each of these layers and what can that tell us about the history in this region. What was happening millions of years ago on the places we stand. Dallas-Fort Worth, long before humans, at the time of the dinos, was experiencing the gradual rise and encroachment of the ocean, moving closer and closer and closer until it eventually arrived. This was the time of the dinosaurs. They were walking across the beaches of this slowly advancing ocean, and actually, we can find their footprints at the Dinosaur Valley State Park. So here we have the Glen Rose limestone. Now, what limestone represents is a time when the ocean is still very shallow. Shallow enough that the critters only a few feet down still receive enough sunlight to survive. So we know that the sea was not yet very deep. On the beaches of this sea, we had those dinosaur footprints. Now what you see through time is a battle between rivers depositing sand and trying to build up the land, and the ocean trying to rise and overcome that sand pile. So it's this constant tension in the past, this story of which one is going to win, the rising sea or the rising sand. And we track that story through all of these units. Here we have the Woodbine Sandstone where we're standing today. This represents a time when the river was beginning to win. We have in the far north near Oklahoma and Arkansas the gradual tectonic uplift of mountains. They're no longer there, but we have evidence that they were. As those mountains rose, they shed sand grains along rivers just like the one we see today. And that sand built up. It built up the beaches and allowed the land to continue to rise in competition with the sea. But eventually, those mountains died down, they were eroded away, the uplift of the ground stopped. And as those mountains died down, the sea began to win. The sea rose and rose until eventually there was this oxygen poor environment where everything that died fell into this muddy, low energy environment. If you've ever walked around after a storm, you'll find mud only in the gentlest puddles. Mud likes to lay down when it's very calm water conditions. So we know that this was deep enough beneath the ocean that things were calm and that mud could settle down. So here we have this buildup of shale through time, of mudstone. This mudstone turns out to be very productive for oil and gas, and much of the oil and gas that has come out of Texas comes from environments like this, the Eagle Ford Shale. This is a oxygen poor environment where everything dies and is well preserved. But even this changes through time. As time goes on, millions of years after that, the sea begins to rise again, and soon oxygen-rich waters pour down into the depths. And you have small critters named coccoliths. These are about the size of a grain of sand. And they were thriving during this time in the oxygen-rich ocean as it continued to rise above the Metroplex area. If it were here today, it would be taller than almost all of the skyscrapers in downtown Dallas. These small creatures, these coccoliths, would live and die in this ocean. And as they would die, their small skeletons would rain down on the ocean floor beneath. Now again, they're only the size of sand grains, but as so much time passes, they build up a layer that's hundreds of feet thick, full of these skeletons, these sand-sized skeletons. We learn this whole sequence simply from looking at the deposits beneath our feet. This battle between rivers depositing and building up the land, seas advancing and consuming the land, and ultimately, our story is one where the rising ocean wins. And this whole sequence you can experience just by driving. If you get in your car in Dallas and you drive across Arlington into Fort Worth, you're actually traveling through millions of years of history. You're going back in time. It's almost as if your car was a time machine, taking you through 15 million years of history back to where the dinosaurs were. Or you could travel into the future, driving from Fort Worth to Dallas. This is all what we can learn just by looking at what's beneath our feet. So, we were just looking at sand that was deposited over here. It's the Woodbine sandstone. Now, we've walked over here and we're looking at shale, at mudstone. So we're walking up through time. Now, if you remember, this is the stuff that's laid down as very gentle water at the bottom of the ocean as this mud slowly settles down into these fine layers. And you'll see when we look at this stuff that it looks really different. It doesn't look like the sandy beach material. Instead, it looks like thin chips of mud. So if you look inside your box of rocks, you'll see an example of this stuff. This is the Eagle Ford Shale. And it looks kind of like mud that's hardened, because that's what it is. You can see it's really thin. I can break off little pieces of this. It flakes off. Look at this. I can flake it off in the layers it was originally deposited as. And you can see this in the sidewall here. You can see layer after thin, thin layer building up through time. So you can imagine this would take a tremendous amount of time if you're just laying down thin sheets of mud year after year. And in fact, it does take millions of years to build up the thickness that we see today. You'll see something else cool here too. Look at this. All of a sudden it goes from this deep blue color mud to this sandy pale unit here. What is that? Well, actually, that's volcanic ash. Yeah, here in the DFW area, millions of years in the past, there was volcanic ash raining down on the landscape and getting buried in these seas and being squished by even more mud after the fact. So that when we come back here today, we can see evidence of a past volcanic eruption.
And here we are at White Rock Creek here in North Dallas. As you can see, the creek, the rocks are white because that is the Austin chalk. So the Austin chalk is a sedimentary rock. It's a limestone. It's made from calcium carbonate, which is actually microscopic seashells. And it was formed in a warm, clear sea far from the shoreline about 85 to 90 million years ago. So it took about 5 million years for it to deposit. It's approximately 400 to 700 feet thick, just depending on what part of the formation you're looking at. And the sea that it formed in was deep enough that the buildings in downtown Dallas would have been covered by the water.
So here we are in the middle of the Woodbine sandstone. If you look inside your box of rocks, you can see an example of that sandstone here, that sandy looking stuff. Let's take a look at it closer up. So look at this. Here we have these thinly laminated sand units, just like we were seeing in the modern day stream. Only these were laid down 100 million years ago. So this sand was deposited as the dinosaurs were walking across that beach. And in fact, if you go over to Lake Grapevine, you can see examples of these dinosaur footprints walking across the beach deposits. So I hope you learned a lot about the rocks underneath our feet in the Metroplex. It's been really fun talking to you about this whole history of dinosaurs and mountains and streams and beaches, and I hope that next time you're out in your backyard, you look and see what you can learn about our geologic past. Now back to James with the STEAM activity kit.
Now that we've seen sedimentary rocks in the field, now we're going to come to the lab, and it's time to open our STEAM kits for the sedimentary rock experiment. In the kit, they'll have 3 rocks that you would have seen in the field: the Woodbine Sandstone, the Eagle Ford Shale, and the Austin Chalk. So we're going to start with the Eagle Ford Shale. So where I'm standing at the DFW airport, if I was to dig a hole straight down, I would run into the Eagle Ford Shale about 30 to 40 feet below my feet. Shale is basically mud that has been compacted over millions of years to form a rock. That's all it is. It's mud. But if you use the magnifying glass provided, you really cannot see the grains of the material in the rock because it is so fine-grained. However, you can see that the rock forms in layers, especially when you were out in the field. You could see in the cliff sides the layers of the shale. Can't see it as much here, but you look really close, sometimes you could see some layering of the rock. This is the Woodbine Sandstone, and if I was to go about a mile or 2 east towards Fort Worth and dug down, this is what I'd run into. So sandstone is basically that's what it is. It's sand that has been compacted over millions of years to form a rock. And sandstone, you can really see the sand grains. So if you pull up your magnifying glass and look real close, you can see all the individual grains of sand. In addition, this is a good sample because you can see all the various layers of the rock, the different color sands that have formed this rock. Many times, this is a lot of our groundwater aquifers where we get drinking water from are in sandstones because it's a very porous rock. Unlike the shale, where the shale is a very competent, it's more of an aquatar to aquaclude. Water does not move very quick through the rock. And finally, the Austin Chalk. If I was to go all the way to Dallas and dig down, this is what I'd run into, is the Austin Chalk. So Austin Chalk is basically a limestone. A lot of limestones have fossils in them. The Austin Chalk does not. Very, very few fossils throughout the Austin Chalk. If you look real close at it through the magnifying glasses, again, you cannot see very many grains. Even under a microscope, the Austin Chalk, it's very difficult to see any grains in the Austin Chalk. It's almost like a paste, I guess, if you look at it. So those are the 3 rocks that we have in the DFW area. Okay, now we're going to start our experiment. So first thing we're going to take is our measuring cup that has the milliliters 50, 75, and 100. So mark those with a Sharpie in advance of starting the experiment. So we're going to take the pea gravel, using our scoop. We're going to fill this snap container to about the 50 mark. Then we're going to take some water and just cover the pea gravel to about 50 milliliters. Then we're going to shake it up. That simulates a rainfall event in the sediment and the pebbles running off. And then pour that in. And if you need to use the paper cup, you might have to cut off the end for the pea gravel to come through, but you don't have to. Now we're going to do the black sand. So this one's still going to measure to about 50 with the sand, but we're going to fill the water to the 100 mark. And shake it up. We're getting a little more water because the sand sometimes is hard to pour out of the cup when there's not enough water in there. So quickly dump that in, shake it, make sure as much sand as you can get out. Next, we're going to do the brown sand. Again, do about 50. And then again about 100 with the water. And you shake it up, simulating that rainfall event again. And quickly dump it in, shake it out. So as you can see, you're already starting to see the layers. Turn it a little bit, you can see the rock pebbles, the black sand above that, and then intermix with the pebbles, and then the brown sand. And then all this material, all this fine-grained material up here is going to slowly settle out over the next, you'll start seeing a layer form as soon as 5 minutes, and then 15, and then an hour, and even 24 hours later, almost everything should settle out. So you want to cap this and set it aside. And then, of course, I did this experiment a little earlier today. So you can see already, the water's still a little cloudy, but there's that thin layer right there of the fine-grained material that's settled out. And as time goes by, it'll get a little thicker and thicker, and then probably tomorrow if you come back, all the water will be clear. And then at the end, if you want to simulate another stormwater event with all of these layers getting washed off into a storm event, take the jar you did your experiment in and shake it up. Watch the water shooting out of it too. And then you can let that settle out over, again, 5, 10, 15 minutes, an hour until the next day. And then you can see all the different layers settle with that one. Of course, I did that experiment earlier. Now you can see on this one, you can really see that, especially on this back side, this layer of sediment that has settled out. And all the pebbles, black and brown sand, have all mixed together below, and you got this thin layer there. And this is how sedimentary rocks typically form in the environment. They just build up, and pressure builds on top of them, and eventually they'll turn into rock. As you continue to explore these concepts in your classroom, we encourage you to share your progress on our website. You can upload pictures of your scientific discoveries on our Earth Learning in Action tab, or send us your questions with the Ask a Scientist feature. Whether you are at your school, the airport, or your own backyard, nature is all around us. So get out there and explore your local environment. It is naturally amazing.